Apache Kafka, obviously, Go and grab it. So, and I'm passionate to it. I love it. I love the simplicity of the software, and we have been using it in Loyalty One. So I think it's natural for me to actually just make one and have all the loggers here share the experience about Kafka and see that and make the day happier. So so created February, but first meetup is it takes a long while to actually make this happen. So April we try to put them together. So I just want to know so how many people are using Kafka in production? Nice. So anyone who has been playing around with Kafka, even a log backup or experiments or something like that. So awesome. So I myself has been playing around them in experiment, and we are trying to put it into a little bit of production in. Sorry. I think this is good. I use this one, it's better. So rather than all the static. So we're trying to, we're trying to use that in Loyalty One, and today we are trying to have a talk on that, and we do have Adam on Flip that will deliver a more technical talk about Kafka. So first thing first, I would like you, so this is the sign up page for the Kafka meetup. And we are all loggers. We like to log because we know that that's the most natural form of information, I think. So to join us and join us at the meetup, and we have a lot more fun coming up. So we already actually thanks a lot of people that try to organize this event. Without them, it would not happen. Actually, 90% of the work is done by Merdan, Montez, and Ron. So they are awesome. Like I was like on the Slack channel, like seeing them going back and forth, like organizing talks and all that. And I was like, that is my first time, so I'm learning a lot. Also, Toronto Scala Meetup. So it's a little bit joint event here, and Sean has a lot of input. Help me out here, so that's a round of applause for him as well. So tonight's agenda. So if you're not already getting bored with me, so I will be actually the first speaker of the talk, and in between we will probably have 15 minutes of break time so that people could take a break, and then come back with a technical talk from Adam from Flip. So, and then we'll enjoy the networking at the end. So, yes, enjoy. If you are not getting bored with me, I'm going to deliver my first talk.
How you find out your documents here?
How you find your documents here? Yes. So this is a little story. It's like I'm not organized, but I'm actually doing chaotic management here. I like memory grid a lot. Like I don't persist my knowledge to folders. I have it in my head. So this is like a memory grid I have. I could actually pull out any single one here. Let's say, oh, I can talk about a little bit on this. So it's a lot of time to come up with something like a meetup. And even the logo, it took me like 2 days to think about it. So I was like, it's very boring that Kafka only actually scale on the right side, but it doesn't scale on the left side. So that on the left side, there's nothing. So it's not quite balanced. So I'm obsessive compulsive, like I like things really neat and all that. So I was like, okay, let's balance that with Toronto. So then naturally that goes into being the logo these days. So I hope you guys like it. If you have really an idea about what the logo is at the end of the day, tell me. I would gladly change it. So that's a little bit story about my chaotic management mode.
All right, hi. There's still a few in the kitchen, but well, they'll find this. All right, so tonight I'm gonna, so can everyone hear me fine? No problems? Okay, good, all right. So tonight I'm gonna be talking about Kafka and Spark, and I'm gonna be going into some details about how Kafka works, and then I'm also gonna be talking a bit about what we do at Flip. Okay, good. So first, a little bit about me. My name is Adam Belmer. I graduated from the University of Waterloo in 2009, a software developer. And I currently work at Flip. And I've been at Flip for just under 2 years now. It'll be 2 years in June. And I work there with our data personalization team. So like I mentioned, it's a two-part presentation. First part, I'm going to go into Kafka. I'm going to talk about different parts of Kafka, how they work together, and the sort of services that you can expect from it. And I'm going to do a brief QA between part 1 and part 2. So if you have any questions about Kafka, the service in specific, let's try to answer them then before we go even deeper. Part 2, I'm going to talk about Spark, I'm going to talk about Kafka, and I'm going to talk about what we do with it at Flip right now. So first is the traditional what is slide. So we all know it was made by LinkedIn. And Kafka is a distributed publish subscribe system. So what that really means is you can publish messages to different topics, and you can consume those messages in a variety of different ways. The nice thing about it being distributed is that you can have access to these messages in all sorts of different areas of your organization or in your application's workspace. And with all of that flexibility also comes a lot of opportunity for removing data duplication and doing all sorts of other cool things. Kafka is high availability if you configure it right. So you can tolerate node losses, you can tolerate outages, you can tolerate all sorts of other disruptive behavior that you've come to expect to be handled by any sort of big data solution. And Kafka also offers high data durability. So just some technicals. I kind of just stripped all the numbers out because, I mean, they're important. Extremely high throughput. So we're talking like 1,000 records per second for like a 3-node cluster with nothing too fancy out of the box. So like M3 large even from AWS or an M4 large. So the benefit of Kafka is that you get a tremendous amount of throughput very easily out of the box. You get very low latency. So I believe I'm not citing figures because they're somewhere else on the internet. You can go find them, those sources. But 99% latency is if you co-locate it in your servers, if your servers are co-located in like the same data warehouse, you can expect like a 3 millisecond latency in like sending or receiving messages at the 99th percentile. When you're getting to like 99.99, it gets into like 14, 15 milliseconds. But essentially it's very, very fast, and it's not likely to be a bottleneck in your system for almost all purposes. In addition, with multiple language clients. So I mean, we use Spark, and because we're using Spark, we program pretty much exclusively in Scala. There's a few people that prefer Python at our company in a different group. But with Kafka, you also have Perl, or no, not Perl. Actually, I'm not sure about Perl. We have Java, yeah. We have PHP, Ruby. You can get C, you can get C++. You can get like Node.js. There's HTTP REST interfaces as well. And then you can also just use plain old like Linux tools. So with your standard in, standard out, you can use those, pipe them into your own applications, and then broadcast that data or receive that data. So there's a lot of flexibility around it. My preference obviously is Scala, because I feel that with Spark, there's a lot of really well-written solutions and configurations and options built around that. So a lot of that stuff is sort of handled for you. Okay, so I was sort of torn about how I was going to present all the different parts of this system, because the thing is, I can't really mention one part without another part being mentioned in reference to how the first part behaves on the second part. And because everything behaves all together, you have to start somewhere. So I'm going to be talking about the parts in an order that I think is appropriate, but I'm also going to be saying, hold on, I'll talk about that part in a little bit when I'm mentioning future parts. So just try to bear with me. There's 4 parts, and then I talk about some of the high availability stuff. So we'll get through those, and hopefully I'll be able to paint a picture about what Kafka is doing under the hood. So right here on the screen, you can see that we have multiple producers, and each producer grouping has an arrow pointing towards the Kafka cluster. From the Kafka cluster, there's multiple arrows coming out pointing to consumer groups, and those consumer groups have multiple consumers in them. In essence, what's happening is the producers produce the messages, they go into the Kafka cluster, and then they come out of the cluster when the consumers request those messages. That's it. That's what Kafka does. Now, when it does that, the way to do this is that you need to divide up your data into topics. So a topic is really like a logical collection of data, and you need to decide what constitutes a topic. A topic could be all of the output from one web server, and each web server has a different topic. The output could be something like, let's say you have multiple applications at your company, and those applications are distributed, but you want all of the logs from all of one application in one topic. So that's where you would have multiple producers producing to a single topic. The way that you structure your topics is going to be up to you. So you need to figure out your data management process. But the topic actually gives you a lot of flexibility in how you go about doing this. And it's also really easy just to make new ones or to split off from old ones. So you end up with a lot of options. So on the screen here, you can see that there's a topic. The producer arrows are pointing at, okay. So the producers are pointing at the end of the queue here. And these are the messages that were just written recently. The consumer has its own pointers, and it points to the messages that it's just read the most recently. So there's usually or often a delta between the consumer reads and the producer writes. Those are the messages that have yet to be consumed by that consumer. Now, one of the cool things about topics is that that they have a key value pair structure. So just like a hash table, you can specify a number of partitions in your topic. In this case, there's 2. And you can use any sort of algorithms that you want to distribute those messages to different partitions. You can use round robin. You can use always just write to partition 0. You can use a hashing algorithm. And one of the, I'll talk about that in the application part, but the fact that you can control which data goes into which partition gives you a lot of control over data locality. And that data locality can really, really help you with your parallelization, with your user preferences, your machine learning, and a variety of other things. So that is an important component to topics. So the topic is the container of the data, whereas the producer is obviously the producer of the data, writes the data to the topic. So one of the benefits about partitioning the data that I just talked about in the previous slide is, let's say you use the user ID and you hash the user ID. What that means is for every user with a given user ID, as long as that ID is constant, like you set it with a cookie or something, if that ID is constant, that user's data will all go to the same partition, which means if you're consuming data from a topic, you only need to read that partition to get that user's data. You don't have to look at any of the other partitions, and basically you can reduce the number of messages you read tremendously, really increase your throughput, and won't spend all your time just filtering through useless messages. So one of the things about Kafka, now that we're on producers, but one of the things about Kafka is that Kafka doesn't care at all what you write in it or how you write it in there. It doesn't care. You could literally just create a producer and pound on your keyboard and it'll be happy to accept that. Doesn't care. There's no control. There's no real restriction. So what that means though is everything is loaded onto the client. So you, the client, need to ensure that you're doing everything the way you want to do it and that you're doing it properly. And this is one of the reasons why I really like using Spark for a producer. Spark with Kafka, has a tremendous amount of support and libraries and all the configurations, everything you need, basically, so you don't screw yourself over. And it works really, really well. So because it's up to you when you're writing your client how you do these things, you get a couple of cool options. So you're not restricted in any way by Kafka, and Kafka leaves us all up to you. So a really good example of one of the more important options, or one of the more important choices you're gonna have to make, is the speed versus integrity trade-off. So when you're producing your messages, if you don't really care if you get all the messages, you can use no confirmation, which is you just throw the message at Kafka, assume it reads it. If everything works fine, you get a very, very high throughput. This is actually the highest amount of throughput you can get. There's no confirmation, you just fire and forget. I don't actually know of too many services where that would be something that you would want, because it does mean that you can lose messages. But if there's an application, I'm sure someone has found one. Confirm once is another good, is one that is very good. So what that means is that when you send the message, the broker, which I haven't talked about yet, one of the brokers receives the message and says, okay, I got it, and fires a confirmation back. Just one confirmation, no replication. So what that means is if that broker says, I got the message, and then the broker dies immediately thereafter before it replicates that out, that data is lost. But you're a lot less likely to have data loss, but there is still a chance you can. So the third and most secure would be confirming all replications. So if you have 3 replications, you send the message, all 3 brokers respond back saying got the message. If you're dealing with highly sensitive information or it is absolutely essential that you get that message, you need confirm all replications, like financial transactions or something that could be potentially ruinous to a person if that message didn't get through. And because it's up to you when you're implementing your producer on the client side, like I said, they don't care what you put in there. You can use different serialization engines as well. So we used plain text, but we've also used Avro. So Avro is a format that, actually I talk about that more on the application side. So anyways, it uses plain text in Avro. I'm gonna talk about that more a little bit later in the presentation. Yeah.
Would you be talking about, so you briefly mentioned how there are various ways to shoot yourself in the foot, and you thought Kafka saves you some of that. Would you be commenting and elaborating on that later?
Okay, so the question is, there's various ways to shoot yourself in the foot. Will I be elaborating on that later? Yes. Yes, I will. More on the application side. We've shot ourselves in the foot a few times, but nothing terribly bad. But yeah, I'll talk about that. Okay, so brokers are the node. Brokers are the core of Kafka. So if you have a 3-node cluster, you're gonna have 3 brokers. The brokers handle all the writes from the producers, handle all the reads from the consumers. It manages where the data is. It manages which topics are in which brokers. And for consumption, basically it's just like the core. It also manages the storage though. Now this part's very important. So Kafka does a lot of random read writes because when it's the producer is producing, it's writing, it's reading, writing, reading, writing, reading. So there's a lot of I/O going on. So it's important to have, I think you could have network storage, but you're gonna end up with a lot of latency when you're doing like the reads and writes over and over and over. So you really wanna have like local disk storage. Also, everything is written locally in logs. And when we were troubleshooting, you could actually go into your logs and see the messages as they come in. So it was actually kind of under the hood, it shows that Kafka, like it does what it does very well, but it's not particularly complicated from the outside looking in. It seems to make a lot of sense. I haven't really looked at the code base, but a lot of the ways that they do things is basically you have a big list and you add messages to it. When you look at the file, guess what? It's just a big list and they add messages to it. So their topics and their files really mirror each other quite well. So the thing with brokers is that they have a lot of responsibility. So this picture here, I borrowed from the internet somewhere, but it actually really illustrates what brokers do very well. So looking at this, there are 4 partitions, but as one topic. There's 4 brokers, and the replication factor is set to 3. So when you look at this, there's 4 partitions and 4 brokers. Each broker is the blue box on the diagonal, that's the leader. So what that means is when the producer goes to write, it knows which partition it wants to write to, and it first it has to figure it out, but then it remembers. It knows which broker is the leader for that partition. So what this means is if you're producing messages and you're writing to all 4 partitions equally, you're going to distribute the load of those message writes across all 4 nodes. So all 4 nodes will be, moderately or lightly used instead of one node just getting hammered. So that's how they work with that's why partitions are very useful. If you only have one partition and one topic, you're basically just going to be hammering that broker like mercilessly if you're putting tons of data into it. So the more data you have, I think a good rule of thumb is to have more partitions. But if you only have 3 brokers, then it would just repartition it amongst the brokers, but it'll still be more evenly balanced than if you were to only have, say, like 4 partitions on a 3-node broker. Yeah.
So did you say the number of brokers matches the number of nodes or the number of partitions?
So number of brokers equals the number of nodes. A really good metric, like a really good way to, like let's say you have 3 brokers. If you have your partitions as a multiple of 3, that'll mean that you'll have an even number of partitions on all the brokers. So whether you had 3 partitions or 6 partitions, I don't think there would actually be any real like performance difference between those 2. But if you had 6 partitions and you added another broker, then the cluster would be able to rebalance itself, even though it'd be like 2, 2, 1, 1. So important here is that, let's say, so the replications there, you have the broker leaders, the topic leaders. One of the important things here is that because we have a replication factor of 3, we could tolerate the loss of 1 entire broker without any problems. We could actually tolerate the loss of 2 entire brokers without any problems. But let's pretend for a moment that we lost broker number 4. I can't get rid of it, but pretend it's gone. So what happens is, at first, the topic 1, partition 2, so the 2nd row, and the 3rd row, and the 4th row are now under-replicated. So the Kafka cluster knows that it's now under-replicated because it can no longer find its other nodes. So the first thing it does is it starts re-replicating that data, and that's for the nodes that still have leaders that are alive. So rows 2 and rows 3, the leader's still alive. They don't have to go through an election. They just start replicating the data, backfilling it into broker 1 and 2, trying to get back to replication 3. The 4th partition lost its leader. So what's going to happen is the broker 1 and broker 2, once they can't find their leader anymore, they're going to, this is where Zookeeper comes in. They're going to say, hey, Zookeeper, we don't have a leader anymore. What do we do? And Zookeeper says, well, have an election, as always. They have a little election, one of them becomes a new leader, and then they start replicating the data over again. I know both those steps happen. I don't know if they happen at the same time, if one happens before the other, but those two steps occur very closely one after the other or at the same time. They're both essential because right now, if Kafka tries to write partition 4 and the leader's gone, it's not going to be able to write that data until a new leader comes in. It can still write data if it's under-replicated, that's no problem, but it can't write data without a leader, so it has to get that leader elected as soon as possible. Okay, so I went through producers, brokers, topics. The last big component is consumers. So consumers, much like the producers, it's entirely up to you as to how you consume the data. Kafka is not going to hold your hand, it's going to just let you consume it. So you register a consumer on a topic or topics. So you can be consuming from multiple topics, but really each topic that you consume from would basically be its own consumer. So just think about it, one consumer per topic. The important thing about consumers is that and I'm going to, if there's time, I'll illustrate this later, but if we're running late, I won't. But basically, belonging to a consumer group is very, 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 very important. A consumer group is a name, basically it's a named offset, and you share that offset with others in that consumer group. So if you're all, let's say you have a group named Group A, and everyone registers as a consumer in Group A, let's say you have 4 consumers, they're going to be consuming all as Group A. If you register a new group, Group B, and you fire up the consumer, it too is going to get all the same messages that Group A was getting. But the thing about it is if you were to add like a new consumer to Group A, it would just rebalance and Group A would just share in the consumption of the messages. So this is really, really important. And if you don't set it, I think you just go on the default group, which is pretty bad because if anyone else is on the default group, you're going to steal their messages, they're going to steal your messages, and you're just going to have a mess. The other important thing about consumers is that the number of partitions you have in a topic limits the number of consumers you can have in a group. There's no limit on the number of consumers in total, but if you only have, say, 16 partitions in your topic, you can only read with 16 consumers, no more, ever, end of story. And that's a big deal, because if you set up your topic at the start and you don't have enough partitions, wait, does anyone know, can you repartition a topic? Okay, yeah, you can repartition. I thought you could, I wasn't sure. So like then you'd basically have to repartition your topic, and I don't know, sort of a pain, but really you need to make sure that you have enough partitions for your consumers to read from. And obviously you can reread previously read data, so you can manually set the offset if you want. So if you know exactly when you want to start reading, you can go and set the offset there. You can just say start at the start, you can say start at the end. So there's a lot of flexibility in where you read your data from. Now, much like the producer that had those verifications, so whether like fire and forget versus make sure all the brokers respond with a confirmation, with consuming, you pretty much have the same thing as well. Kafka will be more than happy to just fire messages at you and hope that you receive them. So that's called at most once delivery. And that basically falls under the at most once delivery into Kafka. You'll send most of your messages and most of them will get there, but you will lose some. This is the same thing coming out. I don't know why you would do that. I'm sure there's reasons why, like maybe if you're handling like packets that you can lose and it's not a big deal, but for our use case, we're actually on the second one, so at least once. This one's great because it's really easy. I think it does that right out of the box. You don't have to really configure too much stuff. Essentially what happens is the consumer will consume a bunch of messages, and once they're consumed, it will tell Kafka, hey, I read those messages, give me some new ones. So let's say you're consuming those messages, doing some stuff, your consumer goes down. You bring it back up. Kafka doesn't think you've read those messages, so it just gives them to you again. Not a big deal, as long as your workflow is idempotent. So whether you do something once or you do it 10 times, doesn't affect the outcome. Not a problem. You get the medium level of throughput with this one. And lastly, exactly once delivery. So this one I've not implemented. And when I looked into how do you do this, it is doable, but it requires that the client itself manage its own offset. So instead of asking Kafka or Zookeeper to manage its offset, the client has to manage its own offset. And to ensure that you have exactly once delivery, you essentially need to be able to atomically store your data and the offset. And if you can't do that, then your exactly once won't work. If anyone has done exactly once, okay. So if I'm wrong, let me know later, but I'm pretty sure that's how that one works. Because essentially you need to be able to both get the data out of the consumer and store the offset at the same time. Because if either one of those fails, then you're gonna be in a state where you're gonna have at most once or at least once. So for like financial transactions, you're gonna have to figure that stuff out. Okay, so I mentioned Zookeeper. This is the last component of the whole Kafka service. So Zookeeper is like the go-to when it comes to arbitrating elections and finding new leaders and stuff. So if you run a Hadoop cluster, I'm sure you already have Zookeeper in there. So it is a dependency, but I don't think it's an unreasonable one. So it lets you elect leaders, and it also manages some of your topic configurations. So that would be like which topics exist on which brokers, how many partitions are they, where are the replicas, who's the leader, what configurations are overridden for which topic, and so on, things like that. So when you're consuming messages, is it consuming? I think you ask Zookeeper like, hey, where do I get my messages from? And it just tells you, go look at these brokers. So if any of that changes and you try to get the message and it doesn't work, your consumer's gonna go back to Zookeeper and say, hey, where did that guy go again? And it'll just redirect you to the new one. There's also some new features in 0.9. I'm just reading these out because this may be stuff that appeals to you, but there are quotas. So this is something that allows restrictions placed on how much a client is allowed to read or write data. So I'm suspecting that this is probably due to, let's say you have a normal producer that produces 1,000 logs a day, and someone checks some code in and it throws exceptions and then it just spams the heck out of it with exceptions. So let's say you put like a 10-fold cap on it. Once you have, 9,980 lines of exceptions, it throws a cap and says, okay, no more. So then you're not gonna end up paying like all the data transfer costs and having to clean up all this mess afterwards. I'm sure there's other reasons, but that's one of the ones I thought of. There's also controls. I only wrote the 3-letter acronym here of ACLs. I wanna say access control list, but I know it's not. But it's basically who is allowed to read and write to which group. And this one is really good because if you have a Kafka cluster, Kafka, like I said, Kafka didn't really care who wrote what to where or who read what from where. So there's obviously some security issues around there, especially if you're dealing with sensitive information. So I haven't looked too much into these ones, but I like that. So these came out in 0.9, which is, I think we're at 0.91 now. So this is still relatively new stuff, but they're going in the right direction with some of these things. So there's still a lot of support going forward, which is pretty good. Oh yeah, also if you're running an older version of Kafka, like 0.8 or before, all your offsets are committed through Zookeeper. So with 0.82, it allows you to commit them through Kafka. That becomes important when you're starting to do stuff with monitoring. At least that's what we found out. So that's just something to be keep in mind if you're using an older version of Kafka, you may need to upgrade. Okay, so that's the end of Kafka as a service. I kind of blew through that relatively quickly. I tried to get everything in, but not dawdle too much. So if anyone has any questions about topics I covered, things I may have missed, statements I made about Kafka as a service or its structure, now's a good time to ask before we go into the applications.
I have a question.
Yeah.
The cluster you're making for Kafka, you have one server and 3 clients on the installation?
So the question was the cluster I'm making for Kafka has 1 server and 3 clients on installation. Okay. No, I'm sorry if I said something similar to that.
Can you set up 2 servers of Kafka?
Yeah, so the way Kafka works is like you can have a single server and it'll do all your message delivery and handling and everything. There's no problem with that. The only thing is that you don't have the parallelization and you don't have the high availability. So if that server goes down, you have to bring it back up before you can use it again.
So what the Kafka clients do?
So, okay, so here, let me just go back to this diagram here. So for those on the web, I'm pointing at the producers. So the producers and the consumers at the bottom, these are the clients. So these would be running, like let's say you're running a Spark producer. This will be running in your Spark cluster, and it will need to be able to access the Kafka cluster. And the brokers, in this case, I had 4 brokers in that one example. Those 4 brokers would be right in the middle here in the Kafka cluster. Does that clear it up?
Yes.
Okay. Does anyone else have any questions? Okay.
Can you talk a little bit about Confluent and how that changes things using their platform?
I was asked, can I talk a little bit about Confluent and how that changes things using their platform? I've heard really good things about them, but I don't actually know. I know one of my colleagues was kind of looking into similar stuff before, but I'm kind of just stuck with the vanilla.
So like you mentioned that messages can be replayed by resetting the offset or something. And they might be getting stored in the broker itself. So how long does broker keep those messages stored in itself? For example, 2 days, 5 days?
Right.
Or is there any limitation till when you can play it back?
So the question was, if you want to play back messages in your consumer, those messages are stored in the broker. So that's correct. The messages are stored in the broker. And how long is it that you can keep those messages? I believe the default is 1 week, but you can actually change it to be as large or as small as you want. So right now, recently when we first prototyped our server, we actually had it set to the default, and I'm pretty sure it was 1 week. And what happened was we just started pumping data into there, and we ran out of disk space.
So that was what I was coming to. So when you do the sizing of what should be size of broker, so you take these kind of things in advance, like what kind of data you will be writing daily, and accordingly you size your things or you size your Kafka.
Yeah, so you do want to take this into account before you get started, like how, make a prediction as to how big you think the data will get, and scale it accordingly. But the other thing is that once your cluster is running, you can add new disks. So let's say if you're hosted on Amazon, for example, you could add. This is where you would be adding storage that wouldn't be local, but you can still add like network optimized storage that's supposed to be really good. So you could add this extra storage and say like add 10 gigs or something, or actually you want more than that, let's say 10 terabytes. And you could include that in Kafka, and Kafka would say, oh, okay, well now I can just keep writing onto here if I run out of room there. So then you can add space as you go, and you can also change how long you keep that data on the fly. So you can choose a time period. So you could choose like 6 hours, or you could choose a size, or you could choose both. So you could say like, give me 6 hours or 30 gigs, and whichever one you hit first, start deleting stuff, and it'll do that for you.
And this offset is only related with how consumer is reading it. Producer is still writing it irrespective of when or where you reset this offset.
Yes, that's correct. So the consumer's offset and the producer's offset are fully independent. So let's say your consumer dies, you have no alerting, you go away for a week, you come back, you realize it's dead. Your producer is going to be 1 week ahead and your consumer is going to be way back here. So then you'll have to figure out how do you close that gap. I think there was another question.
What's the, so there may not be a limit on the size of each one of the I don't know what each data piece is called.
The topic?
No, topic, the thing that we.
Oh, the message.
The message, okay. So what's the maximum size? Is there a limit or?
Okay, so the question is there a maximum size on the message itself? So for most intents and purposes, so like basically if it's less than like, I think it's like 512 bytes or like a few kilobytes or something, there's no concern. The only time that there begins to be a concern, I think, is when you start sending files that are, or like messages that are in like the multi-megabyte range or larger. And I think that the issue, so I know that there can be issues. I'm not sure what those issues are, but there's some tuning that you can do to your cluster for, I think it's at a topic level though, it's on a per topic level. So I think you can tune the topic to be like for larger messages. And I think it has something to do with like data loss in between message cycles or something like that. So if you have very large messages, you definitely want to look into that. I'm not entirely sure though on the details. Yes?
You were talking about the topics and the partitions. So if you have 14 topics, how many partitions do you normally use?
So the number of partitions would be based on each individual topic. So having 14 topics is, there's 14, so I'm not sure how many partitions each topic alone would have. But as I was listening to the earlier presentation, I remember saying that like partition the data based on different users. I'm actually, like, as I was thinking about that, I'm like, yeah, you could also do that too. You don't have to use partitions to do that. Because the topics will also be balanced across the brokers, like the topics with different leaders. So I'm actually a bit at a loss to say why you would do one over the other, aside from the fact that you can change the partitions on the fly. So you can resize partitions, and because of that, if you went from 10 million users to 100 million users and your consumers were starting to go really, really slow because they had way too much data to process, you could just quadruple the number of partitions and then quadruple the number of consumers. And you wouldn't have to change your topic and you wouldn't have to change any of your processes. You wouldn't have to stop anything, you wouldn't have to restart anything. You could just rebalance it and add more consumers and that would be okay.
Is it different from how partitions work in MapReduce? Don't you have like key value and all the messages in a topic which share the same key will always be in the same partition? So
yes, that is exactly how yes, that's the same.
So if you repartition it, for example, my data is skewed and I have something like which is having a large proportion of same thing with the number of keys and to double the partition, then will repartition work in this case because there is a limitation that same key has to still remain in the same partition?
Yes, you're right. You are right. So if let's say you quadruple the number of partitions, but your producer was still producing 4 partitions, 0, so in this case, 0 to 1, and we went from 0 to 7, so we quadruple it, it would still be putting things only in 0 and 1. So yes, we would have to, what you could probably do in this case is, you basically have to restart the producer as far as I'm aware.
So is it safe to say that repartitioning will only help when you have those number of keys which can be distributed among the new partitions that you create?
Yes. Yes. I'm not sure what happens. Let's say let's say original algorithm. Oh no, I do think I remember. I think you get an exception. I was going to say, like, if your original algorithm went from 0 to 7 and you only had 2 partitions, I think if it tried to partition it in like number 2 or 3, it would just throw an exception and then stop. So yeah, that would affect it. So unless anyone has any like more pressing questions, I'll move on to what we do at Flip. So the next slide's a big one, and there's a lot of stuff on it, and I'm basically going to show you what what our data flow looks like. So here it is. This is our Spark Kafka architecture. Oh, sorry, yeah.
Question. Sorry, I'm not sure what Flip does, and probably I'm the only one.
Oh, okay.
Would you mind to say, like, in one sentence what
All
you
right.
do?
So one of my co-founders, or our co-founders, is here, so I better get this right. Okay, so Flip is a weekly shopping app, and it's a service as well that we provide to our merchant partners like Walmart or Best Buy, for example. And what that means is, so on your phone, you can download the Flip app, and we have weekly circulars in there from all of our, like pretty much every flyer in Canada in there. So it shows like all the deals, all the flyers, all of that in there. So you can clip things, you can put them in your grocery cart, or sorry, in your shopping cart. You can add favorites to merchants. So you can do a lot of, like basically all the weekly sort of shopping stuff that you would do. So I did mention that we have multiple applications at our company. So the apps for iOS and Android, those are two. We also have a web app, so you can view the flyers online. We have services where we advertise for specific retailers' circulars in an attempt to drive traffic into those circulars. So when we get that traffic in from the web into there, that's another application. So I think, I don't know, I don't want to guess at how many we have. We have less than 100 more than 5. Way less than 100. But that's sort of like that range of different sorts of applications that we have. So we're dealing with a lot of data that relates to users' shopping behavior. You know, things they're interested in, signals of intent for stuff they'd like to buy, or products that they frequently want to see or click. Does that help answer?
Yeah, sure.
Okay. So our architecture here, I'm going to sit on the slide for a little bit, but I'm going to try to be as concise as I can. So on the left, in the bottom left, we have production logs. So these are those services that I was mentioning, and these logs that they create. Sorry, the logs. We're not talking about the logs about when we're serving stuff. We're talking about like beacons, so behavioral beacons. We can detect like if they clicked on something or viewed something. So we collect that information, and right away we flume it to S3. Flume is a service that lets you rapidly copy data, and S3 is our store where we store stuff for durability purposes. We don't want to lose any of this data, and I'm going to talk a bit more about this, some of the pros and cons and trade-offs and things you can do with Kafka instead of Flume or with Flume in a couple slides. But basically it goes to S3, and from there we have our main Spark producer. So our main Spark producer reads from S3, which you can treat as an HDFS file. So it simply watches the file, the data comes in, and it streams it into Kafka. Kafka is the middle block that you see on your, right in the middle, and right at the very top is the main log topic. So that topic is our main log. It has every single user behavior event in it from every single application, and it's all in plain text. There's nothing fancy about it. The Spark stream just puts it in there. And the simplicity of that is that we can take that log topic and pretty much do whatever we want with that data. So initially, for our first proof of concepts, we were tapping directly off that main stream. But one of the issues with that is if you're only looking for one application, you're going to be throwing away all the other application data because you don't really need it unless you're looking at that specific application. So on the left, yes, on the left of the Kafka service, there's a block, and these blocks all say Spark Stream Filter. These are Spark consumers, because they're consuming from the mainstream, and producers. And what these filters do is they do that filtering. They say, I only want application ID flip web. I only want application ID flip. I only want editorials, et cetera, et cetera. So it pulls out those events that are only specific to that application, and then we write those into their own topic. The reason for this is that if we didn't do that, every single consumer that we ever build off that main stream would be doing that work. That work would be replicated across countless applications, and we would have to pay for all of the computer time to do that. So we do it once, only once, and we now provide a sorted, filtered, application-specific stream of data. So this data, let's say you're working on the Flip app and you're on your iOS device, you could just hook a consumer into the Flip topic and start getting all the Flip data.
So was it not possible to write the same logic in the Bloom interceptor and multiplex it to different topics?
Yes, it is. And I'm going to talk about that shortly, but that was one of the, when I was mentioning like the trade-offs, yeah, that's the one there. So yes, there are other ways to do this, but this is what we currently have. So that would be an example of that example data processing app. Let's say you only care about flyers and all you want to know about is like who's clicking on what flyer because you want to have it on a nice dashboard in the office. You can see like, peaks and valleys and like who's looking at what content and stuff. So that example data processing app could do that. And obviously, once you start processing data, like you're consuming it, you can always rebroadcast it back into Spark. You could have application level topics. The naming of these topics often becomes an issue, but we can talk, I'm going to talk about that on one of my next slides. I'm getting ahead of myself. Now, I was asked if I could talk about machine learning and how it pertains to this. So I'm going to talk a bit about our machine learning process and what we currently use Kafka for. So on the far left of your screen, there's the Spark Stream PIO event ingestion. So PIO stands for Prediction IO. So I think we talked about that earlier tonight. So for those who may not be familiar, Prediction IO is a Spark-based machine learning training framework, serving framework, modeling framework. It does all sorts of machine learning stuff. And the way that we have ours configured is that we stream these events from the topics that we're interested in, and we store them into a distributed Hbase event store. So this storage of events is idempotent. You could give me the same event a million times, and it will just be in there once. So this is also why we don't care if we have multiple copies of events coming in. If it's the same event, it's still only going to be one row. It's not going to have multiple rows. Now, further on that Prediction IO workflow, so the Hbase event store, although it's skinnier on this slide, it's still there on the left. That event store is where we pull our events from to do our Spark batch training. So this isn't really streaming or Kafka based, but I just want to outline, we train the model, we save it to HDFS, and then we deploy the model. And with the deployed model, you can then query it to get your machine learning recommendations. So this is how Kafka fits into our system. And obviously, a really good thing that Kafka could do in this situation would be to, once you deploy this model, the serving engine, you could monitor for users' behavior that you just made a recommendation for. So let's say you said, show them product A, and then you wait, and you wait, and you wait, and they never click on product A, and you could be like, okay, well that didn't work. Or they did click on it, and then you could respond, you could change like what you know about that user, what you know about that model, or what you know about that user's state in the live stream. We're not there yet, but that's how that could fit in really well. So there was the question about Flume. Why do we Flume test 3? Versus, now I like saying this word, Flafka. So Flafka is Flume plus Kafka. And we prototyped it, but we didn't implement it. So on the left here, you have, I basically copied our process and sort of simplified it just a bit. We have the production logs, and those get Flume to S3. We Flume in 60-second blocks. So what that means is that the Spark stream producer actually can't start reading, as far as I know, I hadn't figured out a way, it can't start reading that file until Flume stops writing and then writes the end of file. because essentially what happens is Spark will read very rapidly, get to the end of the file, and find corrupted data and then crash. So we have to wait for the file to be whole and complete before we can actually read it. So what that means is that there's a 60-second delay, a minimum 60-second delay between the user's action and when Spark Stream Producer can pick up that data. There's some advantages as to why we, so that's one way. The other way is you can use Kafka, and I think this is what you were talking about with the interceptor.
Like might be you are reading it from file, but isn't it possible to read also from Flume utils in Spark rather than writing it to file to mark end of file, which you will be marking, I guess, by some custom coding.
Right.
But rather read it from Flume utils.
So you could use Flume utils and Flume into the Spark client, right? Right. So yes. So then that's a third option. So I don't have that one here, but that is true. So basically, with Flume, what you can do is you can really put that data anywhere. So what Kafka does is Kafka lets you use Kafka as a channel. The source is the production log, and the sink in this case we could do S3. So if we were to do the Kafka process, it would write all the logs into Kafka, and as they were coming into Kafka, put them in S3. But that channel of Kafka, we could also use that as our main topic and tap off of there. The advantage of that is that would only be a few seconds delay. We could also take Flume and directly Flume into a Spark process, or you could use Flume interceptors as well.
Yeah, I think Flume interceptors, and after that, the Flume thing can directly write it.
Right. So there's a bunch of different options you can use for producing this data, but we had some restrictions, and the restrictions really were there's three of them. One was a system stability thing. I was pretty sure it would work, but I wasn't willing to stake my career on it, so that was one thing. I'm like, hey, you know what? I don't really want to mess up our billing data, for example, because this is where we decide who gets billed what. And if I screwed that up, I think it just wouldn't be good. Like, it'd be bad for everybody. Everybody would be unhappy. Don't want to do that. Also, we'd have to change a bunch of production systems that we're currently running and that have been running for a long time without issues, no faults, no flaws. And there's always that saying, if it ain't broke, don't fix it. So the trade-off for us was, can we wait 60 seconds for our data? And the answer is, yeah, we can. At this stage of the game, we don't need bleeding edge events. It would be great if we could have it for free or without any risk, but unfortunately right now that's not the case. So we decided that, you know what, let's read from S3. That way our processes don't interfere with each other. We don't have to do any production changes, don't risk billing. So there was a lot of decisions that went into deciding not to do that. If you have a greenfield project and you're starting from the ground up, by all means, look at Flume, look at Flume interceptors. You can look at Kafka. I mean, there's a large number of ways that you can put that data into Kafka. So I mentioned Avro format earlier, and actually, I guess I should give a shout out to my colleague Eunice, who's, there he is, okay. Anyways, he wrote a blog post on our company blog today about Avro and why we use it. So a lot of the things I'm saying, I borrowed from his blog post. So thank you, Eunice. Whoops, there we go. Okay, one of the nice things about Avro is that it gives you a key value format. So Avro really, this example at the bottom kind of sums it up very well. So this is a dummy at the bottom. This is a dummy plain text event that I made, but it's similar to events that we get in, by the millions. And what we do is we generate Avro schemas off of these events. So we take, the larger the better. You can take a very large sample size, like a 3 months. Well, maybe not 3 months, that might be too much. Take like a week or 2 weeks, or like take like a few weeks out of the past few months worth of data. Get those events, and then you can use There's different tools out there. I think Kite SDK is one that we've used successfully, and you generate schemas off of those events. And what that means is that these, like for example, in the bottom right here, the sub-event will always be an integer or it'll be null. And the schemas will figure that out. So if you define a schema and it's always an integer or a null, if one day it comes in with a string, well then it's gonna let you know there's gonna be some exceptions and says like, okay, this doesn't adhere to the schema, this is a change, this is like not acceptable. But what it also does is, remember when I was talking about how I don't want every client filtering, doing all this filtering work, I only want to do it once. With schemas, we also don't want people doing all the regexing over and over and over on different applications, on different platforms, trying to pull that data out. So like for one application, you use a regex, not a big deal. Second application, you use a regex, maybe it's a little different. And maybe those two developers figure out like, oh, you know what, we should build a library because like we're both using Scala, we're both doing the same thing, let's build a library to parse it. Over on the other side of the company, you have people using any of the other Kafka clients, let's say Ruby. Well, now they can't use the Scala library, so then they write their own regex, and then someone else in the company writes their own regex. So then you end up with all these different regexes that all need to be changed if there's any changes in your events, and it could become problematic. So with using Avro, you get key values. So when you're pulling events from the pipe, you just say like avro.decode or something like that. You decode the event, you have all the key value pairs there. You could say, you know, give me the date, give me the time, give me the user ID, like give me whatever stuff you want. You don't have to do any of that processing. It's done for you. And you can just use that data. Also, you can manage schemas authoritatively, so you can have a definitive version of the schema that every consumer in the company will ask the repo for and say, can you just give me the update of that schema? Much like GitHub, you know, you get like the authoritative code, you get the authoritative schema too. So then with that schema, you're ensured that yes, you're decoding the events right, you're gonna get the right parameters, you're gonna get the right values in there. You don't have to do any of that work, and there's no replication or duplication of that code across the company. So we started using plain text, and I was like, yeah, plain text is great, it's fine, I don't care. And then Eunice is like, no, you should use Avro. So I became a proponent of Avro. The other cool thing is, if you do a JSON format, you can still use like grep and plain text searching on the JSON and still pull out a lot of that stuff. So you don't really lose much. And if you really want to, you can use binary encoding, so you can get much faster or much higher levels of throughput. But I don't think we've done any of that yet. I think we're still JSON. Okay, so this is all new to me, this stuff, monitoring. So we figured, I found this tool called Burrow, works pretty good. It's also made by LinkedIn. And one of the nice things about Burrow is that it monitors based on Windows. So it watches like the history, it sort of watches like how your messages are coming in and being consumed. So it won't start alerting based on like a threshold, for example. But it can detect, for example, like if your producer says cut out because the historic trend of messages is suddenly like much lower. And it can also detect things like, let's say you have 4 or 5 producers and you lose 1, and then your message production drops. A threshold may not detect that until like it drops below a certain point, but having that sudden like decrease, Burrow could say like, okay, this isn't right here, something's going on. So there's a number of things that it watches for. I think you can also specify some of like your own behaviors as to how it does things. And you can also issue alerts based on these. So, you know, send an email, wake up infrastructure, whatever. But the trade-off, or the one thing that got us, is I was trying to get this to work on Kafka 0.80, and it didn't work. And I was very frustrated until I learned that I needed 0.82 because Kafka, this application only monitors the Kafka committed offsets. It can't monitor the Zookeeper offsets because it doesn't have access to those. So I know there's other monitoring solutions. I haven't looked super hard into them, but this is one that we've used. We've actually had pretty good results with it, and it correctly detected when a few of our systems weren't consuming messages. We had this really nasty bug where our Spark streaming consumer died, but it didn't die. So it was just not doing anything. It wasn't writing. It was still iterating, and it was still looking for events. It just didn't do anything though. So the health checks and the system process managers are like, yeah, it's fine, it's still there, it's still doing stuff. But Burrow was like, yeah, you guys aren't reading these messages, so you should probably figure, you should go read those messages. So it worked really well. Okay, so now there's a few pitfalls. So a lot of these were like mostly trial, like a lot of stuff that I've talked about here, I learned by doing stuff, like trying things and they don't work and then I figure out why. So a lot of pitfalls surrounded everything. Like I didn't have enough partitions, like I made the topic wrong, or like there's all sorts of little stuff that I figured out by like, okay, why doesn't this work? Let me read the help file. Like, okay, well there it is. But these were some of the ones that like I didn't think of and then they just got me. So logging issues. Long running jobs sometimes will have their logs cleaned up due to cron jobs or other like disk management processes. So for one job, we had the producer and we started it like 6 weeks ago and it was working great. And at the time that we created it, it would write its own logs. The Spark logs would get written locally and then they would get uploaded to HDFS. Everything's great. I can see the logs in HDFS. I'm like, okay, there's a start, everything's there. Fast forward 6 weeks later, turns out that every night we delete any logs that are 3 weeks or older. So after 3 weeks of running, we killed the directory that had those logs in HDFS, which wasn't a problem. It didn't know, didn't care, everything was running fine. And then one day that job died. Why did it die? Let's go look at the logs. They're gone, no logs. So that was bad because we had no idea why it died. And we're like, well, all we could really do is, fix the logging issue and start it again and wait for it to die again. We'll look through the code in the meantime and try to figure something out. But so when you're running long-running jobs, especially like us, we were just starting doing this, make sure you know where your logs are going. And make sure that if you need those logs in like 6 months, that even if the start of the log isn't there, or maybe you only keep the start of the log and then you cut everything else out except for like the last week. And you have some sort of like rolling window of logs that goes along. However you set it up, make sure that is there for you for when you need to go back and figure out why something crashed or failed. Another pitfall, naming management. So with naming topics, I mean, this is obviously one of the hardest things in computers. What do you name something? So when you're naming like your topics or like you want to name it something that's accurate, but also isn't perhaps like overly, I don't know, Germanic, or just goes forever. So like, I don't actually have a good solution for this. I think the best thing I can advise is like, based on your own applications, come up with a standard and then try to adhere to that standard. Maybe farm it out, like vet it out around companies, see if anyone has like comments, or and even send it to people who like may not be directly working on it because they may be in the future. And if the name doesn't make any sense to them, like if they have no idea what that is about, or maybe it's really similar to something they're working on, there can be some confusion. And until Kafka has like I was mentioning about that access security, like who can write to which group, who can read from which group, having really strong naming conventions can really help prevent any like accidental, like, I accidentally registered a consumer on production on that billing topic. and I took half of your billing data for the past 3 months. So like, you don't want to have any of that stuff come up. So like, always have really strong naming managements. If you come up with something really good that works really well, write a blog post about it, because not many people have done that. And actually, that's it. So that's really what we do at Flip. It's 9:30, so I'm going to answer some questions, but I'm going to spare you the demo. I was going to give you a little demo about like how producers and consumers and consumer groups work, but I ended in the slides. So if you're really curious, just go look up consumer groups. That stuff's pretty good to know. Yes, we're hiring. I don't know if I'm allowed to say that, but I already did. Everyone's hiring. Okay. Yeah, and download our app. So, does anyone have any questions? Yeah.
Just a heads up, there's construction down in the main floor, which we were unaware of. So they blocked the front entrance. Don't worry, you can leave the building. You don't have to spend all night here. Unless you want to talk to people with hiring and looking for jobs where else you want. And then I'll stay. But if you want to leave, when you get down, if you want to leave, when you off the elevator, just go left and follow right around the path, and you can exit out through the Tim Hortons. Okay, so I don't want you to feel like you're locked in upstairs. That's all. Thank you.
Yeah, and if anyone wants to leave, I mean, just go. Don't feel bad. Hey. Pardon? Did we consider using Amazon Kinesis instead of Kafka? Yeah, we looked at some of that. So I guess there's really two, there's more than two schools of thought, but there's like two primary ones. And one is like, just let Amazon do everything and hope it works. And then there's, we would rather know what's going on so that if anything goes wrong, we can fix it. Because I'm more subscribed to that second school. And I found like Apache, okay, so this is a genuine question. I'm not sure. Does Spark and Kinesis have like a really good integration? So that was a big deal because we really like using Spark. And I think I remembered looking up Kinesis and like, I was like, okay, this looks all right. But I didn't have any way to like plug into it very easily with Spark. Whereas with Kafka, I was like, well, it's right here and it's open source and I can download it and I got it up and running and I'm like, oh, this thing's great. So that sort of colored my whole experience with it. Not saying Kinesis is bad. It was really that Spark integration though that was like, that's what did it for me. I didn't really want to try to write an integration into it either. So that was that. Pardon me?
What aspect of it?
So what aspect of the integration was missing? Like basically what I wanted to be able to do is create a Spark producer or consumer and just say, get your data from here or write your data to there. And like Spark has built-in Kafka utils. So like there's a lot of support around that in the ecosystem. Is there? Oh, okay. So there are Kinesis utils like that. See, I didn't know that. Oh, okay, yeah, and we started looking at this maybe like 1.5 years ago. So yeah, so for everybody, yes, Kinesis does have integrations with Spark. There's people working on that, so that's good. But that's at the time of when we were making our decisions, that's why we went with Kafka. In the back?
Well, as we discussed earlier, some of the issues and pitfalls.
Right. So the thing is like I was trying to think about like what were like the major individual issues that I faced while I was doing this. Like there was just, there wasn't anything that stands out in my mind as being like, oh, this is really bad. Like this is like a brutal, fatal mistake or error. I guess the loggings thing was kind of, I didn't expect that, so that was one of them. And I think the other thing was like I just installed Kafka and everything worked great out of the box, so I didn't really look too hard into the configurations. And then we ran out of disk space, and there was like alarms going off all over the place, and we're like, oh, like we weren't using this in production or anything, but like it's kind of embarrassing. I was like, oh, geez, I pulled up 30 gigs in like 6 hours. Like, whoops. So, I mean, those were, I guess, some of the gotchas around there. So like, I mean, if you were to like read all the documentation, you probably would have seen all this stuff. So there wasn't really anything hidden or anything that was badly documented. It was actually quite a pleasant process overall. Like it was quite easy to set up. And this is also assuming you already have Zookeeper set up. Yeah.
Just sort of further to that, that we've run into some of these technical issues, right? It's embarrassingly easy to bombard your disk and fill up things with logs, especially if you have jobs which are running and being scheduled by mesos or chronos or marathon or something like that.
Yeah.
Some setup. If there's an error and you have that error is sort of runaway job, that can within a span of a few hours that you won't know till the time all the alarms go, fill up the entire disk with just logging messages.
Yeah.
So we've done that, and I think almost everybody goes through the right passage.
Yeah.
But just a perspective for people, this is something which is pretty easy to do when you will run into it.
Yeah. So did everybody get that? Okay, so I'm going to try to paraphrase it as best I can, but it's really easy to bombard your disk with way too many messages. And like, let's say everything's behaving normally and everything's behaving okay, and you're getting a couple thousand messages per second, but then you end up with some exceptions being thrown and suddenly you're just bombarding it with exception after exception after exception after exception. If you don't have strict caps on like how much space you're using, or like your log, if you don't have any strategy around managing your Kafka topics data footprint, you can like bring down your cluster quite easily. Like I said before, and I'll say it again, Kafka doesn't really care. It'll take all your messages until it kills itself. It is very, very good at doing what it does, so it'll do whatever it can to keep up with all your messages, even if they're like exceptions and garbage and you don't want them in there, it'll still do it. So you need to be cautious about that. This is why monitoring is very important. And I'm sure you could probably also look at like monitoring some of the contents of the log. So if you see like a pile of repeated exceptions, then trigger some sort of alarm to have like intervening action of some sort. Yes, question?
Have you tried other serialization framework like Cryo?
So have we tried any serialization frameworks like Cryo? I didn't. I think Eunice did.
I did, but Cryo is not in the ballpark of this type of serialization. Yeah, we can talk about this later.
Yeah, if you want to, he's a good one to talk to about serialization. Okay. Anybody else?
A little out of context, but the Hbase that you were using, it was specifically used for the training of models.
So the question is that is the Hbase that we're using specifically created for the training of the models? Yeah. Yes.
And you have automated it for something like Uzi or something that you frequently you have set some particular process like which is automated in the production.
So right now we automatically insert all the events as they come in the streaming process. But as for like the building of models, we're still sort of fleshing that process out. Like how do we want to build and deploy them and all of that.
And when you score, so simultaneously when you are capturing the event, you are simultaneously storing it in Hbase and simultaneously by some other process you are scoring on it and then sending back the recommendation at the same time, or when does recommendation thing get clicked on that your application right now?
Okay, so I'm just going to back up a few slides here to this one. So really right now, once we train it and then we deploy it, so right here it's acting as like a web service that you can feed information in, like I need recommendations on these things for these people, and we'll return those recommendations for those individuals. But once it's here at this stage in our current implementation, we don't take into account new information until we retrain it again. So maybe we do like I don't know, you could train it, you could do like continuous training and redeploy over and over and over again. Or you could train like every 2 weeks. I'm not sure what like the optimum route would be if we just stayed with a single directional linear path. But I mean, so I'm not really skilled at machine learning. So once you have like a deployed model, I mean, this is a Spark process. You could also have this registered as a Spark consumer and consume things from a Kafka topic. I don't know what you're gonna do with that data, but it's available. So I mean, you could use it. I don't know how to use it, but you could use it.
So right now you are sending recommendations to all in the one single Go and data replace at this point.
Yes.
And do you run a separate cluster for Hbase because of?
Yes, we do. Yeah, we actually, so it's a bit out of scope for this presentation, but we actually run Hbase on a MapR cluster because we do a lot of random read writes, and so MapR's file system lends itself beautifully to that because you're not stuck with writing a whole block of data. You can actually write, I think you can write at like the byte level, or like you can write, basically it's just like a regular old like old Unix file system at the bottom. So when you're writing, like when you're inserting rapid succession tons of events, no problem. When you're reading rapid succession events, no problem. So it actually, like we've seen really good performance out of it.
You mean like you have turned off the memory part of it and you are somehow directly writing this to that sort of thing?
MapR?
Yeah, exactly.
Yeah, we're a lot of the Hbase overhead stuff. So MapR has its own implementation of Hbase, what do you call that? The Hbase services. So it interfaces very similarly, but under the hood, MapR is just writing stuff and reading stuff directly to disk. Yeah. So it's very fast.
Maybe this offline.
Yeah, we can take that offline. So if anyone else has any Spark or Kafka questions? All right, so that's it.
So thank you, Adam,
Yeah.
for giving.
And I just wanted to thank everyone here for coming out to hear me, and it's been an honor, so thank you very much.
So we do have plans for the next meetup, so come on and register on the site, and you get a lot of information about that. So and we are also looking for organizers. So anyone interested in organizing Apache Kafka meetup, please contact me, and we'll arrange something. Thank you. Okay, thank you. Bye.
Great job.
Thanks.
Do you guys